So, next up we have Victor Pereboom. He's the co-founder and CTO of UbiOps, and he will be talking about how we can build production-grade applications for AI. Thank you, Victor.
Thank you. All right, welcome. Thank you for being here, despite the rain outside. My name is Victor. I'm one of the founders and CTO of UbiOps. What we do is we build a data science, like a platform for data scientists to run, deploy, and scale AI and machine learning models when they are going to be used in production. So when they're actually going to be applied in applications and services. So I'm not going to show you any equations today. I am going to talk about a few technical concepts, and it's mostly about the fact that there's a growing need to really turn developed AI models and machine learning algorithms into live services and products. And yeah, it's also because local developed, local AI and ML code that's not implemented, it doesn't have any value. And yeah, of course, that's something that we want to change. So getting ML from the lab to the field, it's a difficult problem. And we also see that a lot of companies are struggling with this at the moment, or at least trying to get to a point to say, okay, we've spent so many hours developing great machine learning models, great AI models. Now they need to run, now they need to become part of a service, part of an application. So how do we get there? And in the end, one of the most challenging things is, you can play around with a lot of technologies to do this, but one of the most challenging things with AI in production is that once people actually start relying on it, and once it's really needed that it runs, all the companies really care about reliability, uptime, and security of their applications. And with AI models and doing that, that's kind of a challenge. Let me give you one example of one of our users. It's Bayer, the crop science department. So what they're doing is they're building an AI model for detecting diseases and pests in farm fields, in crop fields, and they're actually offering that as a service to farmers and to their users. So this is actually an application that's going to be used by people who are actually in the field with a mobile phone taking pictures of crops. It's going to be in the background of applications from that process IoT data. So yeah, it's something that's really going to run. And they're very good at developing these AI models, but in the end, these AI models need to be running in the background of an actual app, of an actual application. And well, kind of conceptually, that's kind of easy, right? So we have an AI model, we have an app, it sends a request, we can have a container with a model in it, and well, the guy on the left is gonna take a photo of a plant, see if there's anything wrong with it, if there are any pests or any things he needs to do with it. But then, if he's going to send a lot of requests, or if there's going to be a lot of farmers using this at the same time, it still needs to run. And I think we have plenty of angry farmers already. So it's something that really needs engineering and work to get this done. And when we zoom into that problem, like that AI model, it really turns into a big set of kind of an engineering challenge to get this done. We don't just have the machine learning model, we have all sets of services around it that we need to put in place to make sure that it scales, that it can process all of the sufficient data, that it's secure, that there's actually also a process to maintain this. And yeah, there are a lot of issues, a lot of things to think about. And reliability is an important thing, like security, also cost efficiency. Like you can build a very big applications by throwing a lot of cloud compute at it, but how do you do that efficiently? How do you manage the cost of the application? How do you scale it? So for instance, this application from Bayer, it's probably used in a couple of months a year, a couple of seasons, very actively, but then maybe a couple of months it's going to not be used. Also at night, the usage will be much lower, of course. And of course, there's also how do you maintain these applications once they run and once they're live. So I'm going to zoom in into three different parts of it, and actually 3 concepts on how to solve this. Of course, there's a lot of other things, but we only have like 15 minutes. So one thing we do is to turn the AI model into a microservice, like a service that is kind of self-contained. Make it easy to manage the lifecycle of this individual service and thing, and how do you play with on-demand compute and kind of smart allocation of resources to make sure it's cost-effective and that it also scales. All right, let's start with the first thing. So we need kind of a layer in between the data science code and the actual infrastructure where the thing runs. So that's kind of the machine learning model ops part, where you actually take the AI model, turn it into a container with all its dependencies, and run it scalably on the compute itself. So the benefits of approaching it this way is that you always know that the code runs in the same way by making it into its own service or container. You can scale it, and you can easily scale it out, and you can also manage, while you're doing that, you can also manage the failover of the application. So once an AI model is running, you don't want one AI model to kind of affect other stuff that's running in production, and that also needs to be live. So those are kind of three of the main benefits. And well, the result is that you have a very high available service that you can scale up and scale down, and can also start up quickly, and can also handle kind of more spiky demand. So what happens in the background? We containerize the code, can scale it with Kubernetes. You give it an API endpoint that you can use, and also put some load balancing in front, so you can have like many services handling requests at the same time. So that model that was first running on a data scientist laptop now becomes a service that's actually scalable and can run on cloud compute. And of course, while doing that, you can also take care of authentication, security, and also this is a service that you can keep track of and can do logging and monitoring for. How does that look like? If zoom in a bit, so we have the cloud side, we have Kubernetes as a scaling layer. Well, we have our own control plane, and that's where, and then on top of that, we have the AI workloads that actually run. So these are kind of the models that kind of the core of your applications and AI-driven products that scalably run there and sit there as self-contained things and services. Then once we have that like individual service, you also want to make it easy to update it and to maintain its kind of life cycle, to manage the life cycle of the thing. Because for machine learning, like a model, once it's made, it usually doesn't stay that way. There are always optimizations that you want to do. There are always there are kind of retraining steps. Maybe you figure out, for instance, with COVID, like, hey, the situation outside is totally different now, so we might to retrain our models. We have a kind of different data drift. So you want to manage this individual service without touching all the other parts of your application or without all the other parts of your stack. So to do so, it's very nice that it's a single service, but also that you have some process to maintain it and to manage the life cycle. Well, that's kind of where the CI/CD comes into play, but also a large part automation, because automation is also the way you actually reduce human error in the loop, and it's also a way to kind of set the process, set the boundaries of what you can do with this service and how you manage it. Yeah, and it's of course treated as a piece of production code. While it was first just like an AI model or something that's been trained, now it's currently, you can handle it as a piece of like production code that's just part of a larger product. Well, this is an example of how we do kind of version management. So you have a single deployment, you have different versions that you can use, and we also make sure, for instance, that transitioning from one version to the next is very smooth, so that you don't have to take everything down, pull the plug, reset it, and plug it back in, but that you actually have a smooth transition, so that requests can keep on running while you actually update something, and which is very nice, because then the end user won't actually notice that they're using a new model. And then the last part is also a very interesting one, because it both relates to scaling and it relates to cost and efficiency, is actually when we have this whole thing and we want to add like compute to it. So we have the way to maintain the service, to build an individual service, and now we need to run that actually somewhere. Can be in a public cloud, can be on your own infrastructure, can be on maybe a hybrid or multi-cloud strategy. But it's great that you can do that in an on-demand way. So the nice thing of these individual services is that you can scale them. So let's say that if there's, with the Bayer example, if there's one day there's one or two of these crop growers actually sending data, sending requests, but the next day there may be 1,000 or there may be 1,500. You don't want to have like the base load of demand built for kind of the peak workload that you're using. So you want to scale that up and down. You want to do that in a rapid kind of way as well, because that makes it very cost efficient. And also be able, for instance, that if your service is not being used at night, that you can actually turn it off and you don't use any resources at all. Yeah, so one thing, yeah, cost efficiency with pay-per-use compute makes it very nice, but also, yeah, you don't really have to care about how your models run. Once they run as an individual service, you can actually you just want to control kind of the boundary conditions, like maybe where it runs, how much it can scale, but not necessarily you don't want to think about, oh, it needs to run on this instance, and wait, there's another instance running, and I have to keep track of all that stuff at the same time. So we also have an option to connect different node pools, and this is kind of a thing that we're seeing more and more, that it becomes more important where things run. 3 years ago, like the cloud, it didn't really matter, like you could use like Google or AWS, but now people start to become more, their needs are changing on where things run. They become more conscious of like, hey, we need to run things inside the EU, or we want to run things on a specific cloud, or we want to kind of have more control and knobs to turn on where our workloads are actually living. So we made something that enables you to actually choose where different things run, and also in kind of a hybrid cloud setting. For this, we also partner with different cloud providers to actually give you the ability to lift and shift workloads around, depending on the needs of your algorithms, depending on where your data lives, because also moving a lot of data back and forth between clouds can become very expensive. So we really did some thinking on how we can help our users to better use hybrid cloud settings, but also make it more cost efficient in that way. And yeah, then there's GPUs, of course, which are also kind of a difficult thing to work with because they're very expensive, and usually they don't scale very nicely, because if you have multiple containers, usually one pod can only occupy like one GPU at the same time. So they're a bit tricky to work with. But on the other hand, they're also very powerful, because for most machine learning models, especially computer vision applications, they're almost a necessity, not just for training, but also for inference and running things in production. So yeah, we made a system to make on-demand GPU allocation to containers and AI models more easy, and also more cost efficient. So we help companies like Bayer also save a lot of money on actually GPU compute in this way, and also make optimal use of the available hardware. For instance, slicing different GPUs, adding multiple like different models or pods on one single large data center GPU, and that actually helps them a lot. And like in the end, we can give them the stability to really run their application and don't care about the scaling and the scaling and the uptime and the availability. They can just focus on building this application and building these machine learning models, and focus on their applying their domain knowledge and managing their intellectual property. So we help them reduce their time to market by a lot, save on cloud spend, and also have a very high reliability and maintainability, which in the end is what AI in production is all about. And yeah, at that point, it becomes really, really challenging. So when kind of playtime is over and people start really relying on AI applications, which is happening more and more, this really, becomes a big thing to think about. Bayer's not the only one. Like we see that like machine learning operations in general as a field is maturing a lot. There are also many like different tools out there to help you with it. Like we're only solving part of the stack, but it's also bigger. And yeah, it's a great, great development, I think. And yeah, new reality where implementation of AI kind of has a profound impact on the competitiveness and profitability of many companies. Yeah, if you want to discuss more about yeah, the other topics or the other things that come into play when you want to run AI in production and want to run production workloads, come visit us at our booth. We're right over there. It's in the other, on the exhibition floor. Well, I hope this was kind of learned something today as well. Like no equations, but hopefully, yeah, a good some technical insights in how we can manage to run AI in production and build great AI applications, which is what we're all here for. So, thank you.
Thank you, Victor. We will take some questions from the audience.
Sure. Yeah, of course.
So, who would like to go first?
Oh.
Hi. So we're talking a lot about machine learning models and AI, and your platform is obviously very focused on AI, but how do you deal with the first rule of machine learning, which is to start without machine learning? Is there also like room for that on the platform, or?
Yeah, so we focus on a specific part of a life cycle where we work with yeah, companies and teams that actually got to the point where they have a machine learning model that they want to implement. So yeah, that's a difficult thing. There are also platforms out there that try to cover the entire life cycle of things. We as a company aim to focus on kind of the niche of just making things, making sure that things are really reliable, secure, and yeah, production ready. So.
All right. Thanks.
Yeah. Thank you.
Hi. You mentioned that the MLOps is maturing. Have you noticed any established best practices take hold with how companies manage their ML AI pipeline, and what trends have you noticed within the space?
Yeah. Good question. It's indeed maturing, but also still very kind of early and nascent. So actually, it strikes me that there's still kind of a lack of really best practices, like industry-wide. That's something that's really necessary right now. The nice thing is that we see a lot of like smaller tools and companies starting to work together to build kind of a basic stack for this stuff. So basic stack for AI, also as an answer to like larger cloud platforms and managed services, which also basically kind of a bucket of different things that you have to duct tape together. So I think that's a very good development. So I think we're going to see much more consolidation in that space, and I'm sure like in the next 1 or 2 years, they're going to be best practices, and they're going to be kind of reference architectures that you can use for this, like MLOps. Yeah, MLOps processes. Yeah.
I think we have time for one more.
Microphone is coming. Oh, on your right.
Hi, I was just wondering, when deploying machine learning models, you mentioned different versions and handling that stuff as well. What about like tracking performance and drift and all that stuff? Is that part of the platform as well?
It's not part of the platform. We integrate with other tools that do that because it's kind of a niche by itself right now. The monitoring, explainability of AI machine learning models. It's also more data science kind of focus because it very depends on the model, what kind of explainability and monitoring tools you want. Of course, we do have monitoring for the infrastructure part to make sure that everything is okay and if there are any errors and issues and that stuff. But if it's really about the AI models, we look more at integrations, which is actually kind of what I mentioned about the MLOps, so kind of integrating with other tools as well that kind of come after us or before us in the life cycle and stack. So.
Thank you so much.
Okay. Thank you very much.